Here are the answers for the day 2 warm-up. Balance each equation. So question A, we have a decomposition reaction showing ammonia decomposing to produce nitrogen and hydrogen. We need to put in coefficients to have equal amounts of each atom on the left and right sides of the arrow. If we put a 2 right here, that gets us our 2 nitrogens to match this subscript. But in doing that, it creates 6 H's on the left side. So we can put a 3 here to get 6 H's on the right. Question B, we have zinc sulfide combining with sulfuric acid to make zinc sulfate and hydrogen sulfide. This is a double replacement reaction, and it looks like it is already balanced. There's one zinc atom here. There's one sulfide over here, one sulfide, couple of hydrogens here, a sulfate here, and a sulfate here. We don't need to put in any extra coefficient numbers, just leaving ones in front of everything is already balanced. Question C, this is a combination reaction, sodium oxide combining with water to produce sodium hydroxide. If we put a 2 here, that gets us our 2 sodiums to match that subscript. Putting a 2 here distributes to the O, creating 2 O's, and distributes to the H, meaning that there's 2 H's, and that's already what's on the left side. Here and here, those are our 2 O's, and that little 2 there tells us 2 H's. Question D. Here we have a combustion reaction. This compound here containing carbon and hydrogen and oxygen is a carbohydrate. Carbohydrate is a compound that contains carbon, hydrogen, and oxygen only. That carbohydrate is being combined with oxygen. The product is carbon dioxide and water. That reaction pattern is called combustion, when you combine something with oxygen and produce carbon dioxide and water. Putting a 6 in front of the carbon dioxide gets us the 6 carbons to match what's on the left side. Putting a 6 in front of the water gets us 12 hydrogens to match what's on the left side. And now let's figure out what we need to do with the oxygen. 6 times 2 is 12 oxygens. 6 times a 1 is 6 oxygens. There are 18 oxygens on the right side of this equation. On the left side, there are 6 oxygens here and more oxygens here. We want that to add up to 18 oxygens. Well, 6 plus 12 makes 18. So what number could be written here so that that ends up making 12 oxygens in that location? We could put a 6 there. Now everything is balanced, the carbons, hydrogens, and oxygens.